Hello, this is the third video of a fourth calculus series on integration techniques for OCR Pure Core Further Mathematics, and we will be integrating using substitution x equals sine u. We have already come across the results that the integral of 1 over the square root of 1 minus x squared dx equals arc sine x plus c, and we know that cos u equals the square root of 1 minus sine squared u because of the identity that cos squared u plus sine squared u is equivalent to 1. We also know that if we differentiate sine u, we get cos u. Given all these facts, the substitution x equals sine u may be useful when we're integrating functions involving the square root of 1 minus x squared. In this example, we note that the denominator is a power of the square root of 1 minus x squared, so we will try the substitution x equals sine u. So, putting that in, we get 1 minus sine squared u to the 3 over 2. Now we have to note that the dx by du would be cos u, so replacing that dx we get cos u du. This will give us numerator of cos u over cos squared u to the 3 over 2 du, which cancels down to 1 over cos squared u du. And using the fact that cos u and sec u are reciprocals, we can write that then as sec squared u du. We are able to integrate this new form of the integral because we know that the standard result is that integral of sec squared u just gives us tan u. There are no limits, so as it's an indefinite integral, so we need to remember the plus c. Now this is equivalent to sine u over cos u plus c, using that identity that tan x is always sine x over cos x. Well, we know that x equals sine u, and we know therefore that we can write cos u as being the square root of 1 minus sine squared u, or 1 minus x squared. Therefore, replacing those sine u and cos u with terms in the original variable x gives us x over square root of 1 minus x squared plus c. Hence, the solution to our original integral is x over square root of 1 minus x squared plus c. You could check this by differentiating this expression. In this next example, we notice that the square root of 1 minus x squared is in the integral. Hence again we'll try x equal sine u as a substitution to see if we can then integrate. Note it's not a definite integral, there are limits, so therefore when we swap in the u for the x terms, we do need to change those limits as well. So when x equals 0, then sine u is 0, gives us u equals 0. When x equals a half, sine for minus 1 of half would give us u equals pi by 6. Note that I'm using radians here. So we can substitute for x we're using sine u, so we've got these limits, u equals 0 and u equals pi by 6. And I've got then the square root of 1 minus sine squared u. Now that dx, I would have had dx by du equal to cos u, which I know from here. So that will give me cos u du. That integral is now totally in terms of u. I know that I can use cos u to replace the square root of 1 minus sine squared u, and I have another cos u, which would give me cos squared u du. You may already know that cos squared u is not that easy to integrate, but luckily I have a double angle formula that I can use. And so I will substitute the cos squared u using that double angled formula to being a half cos 2u plus 1. This I can integrate quite easily using a standard result. That will give me sine 2u over 2, and then the 1 integrates to being plus u. Giving me a half of root 3 over 4 plus pi by 6. And then the other two terms when they're 0. Sine of 0 is 0 and u is 0, so I won't put those in. Giving me root 3 over 8 plus pi by 12. Note here that one of the common errors is in changing the limits. So whereas here we were working with that limit of x equal to 0.5, and some people like to write that in so that they know that they're not forgetting. And then we change to u equals 0 and pi by 6. Note here that in order to deal with the cos squared u, we needed to use that double angle formula. And remembering that we can, this factor of 2, if we want to, we can always take it outside the integral. Doesn't matter, as long as you make sure that you get the right fraction as you go through your working. In summary then, integrals involving the square root of 1 minus x squared may be transformed using the substitution x equals sine u. We will note then that cos u equals the square root of 1 minus sine squared u, using the identity cos squared u plus sine squared u is always 1. And this relates then back to this square root of 1 minus x squared term. Also note that when we differentiate sine u, we get cos u. The resulting integral may need a further technique to be applied, use of a double angle formula, for example that cos 2u equaled 2 cos squared u minus 1, or we might need to use the 1 minus 2 sine squared u and rearrange it so that we can integrate cos squared or sine squared. Definite integrals do need to have their limits transformed for equivalent values for new variable, and if this is something that you commonly forget, then get into the habit of writing x equals and u equals on your integral limits. In the next video we will integrate using substitution x equals tan u.